This is a video for AQA Mechanics, Impulse Momentum section 2.1, where we're considering Newton's law of restitution. Well, we've seen already that in collisions between two objects, where we assume there are no external forces acting, then we look at the momentum, which depends on mass and velocity. But there's another quantity that we need to consider, and that's really depends on the actual materials that are colliding with each other, and we consider what's called the elasticity. Elasticity is found by experiment and really depends on the materials that are colliding with each other. Restitution is then a measure of this elasticity, and we have for any two materials a coefficient of restitution, which is given the symbol E. Newton's law of restitution then says that E is equal to the speed of separation of the collision divided by the speed of approach. Because they're both speeds, then the dimensions of E will cancel out the top line and the bottom line, so we have a quantity which is dimensionless. In other words, it's just a number, and that number lies between 0 and 1. For 0, then we have what's called a totally inelastic collision, and we can see that the speed of separation must be 0 for that to happen, and therefore the objects are going to coalesce or stick together. At the other extreme, we have E is equal to 1, and this is what we call a perfectly elastic collision. So in the next few slides then we'll look at a few examples of how this new equation, the Newton's law of restitution, can be combined with conservation momentum to solve similar situations that we've already had, but where we can have two unknowns. But first of all, let's just look at a couple of examples where we're calculating or using the value of E in this equation. So here we have a situation where the before and after speeds, velocities are shown in the diagram, and we're asked to calculate the value of E. So remember that the speed of separation, well, if we look at the separation, we've got 4 in one direction and 1 in the other direction. So the speed that they're separating at is equal to 4 plus 1, and the speed of approach, got 5 and 2 towards each other, so if you think about that, we have 5 plus 2 as the speed of approach, and therefore E is equal to 5 over 7. In the next question, we're actually given the value of E, but the unknown quantity now is one of the velocities after the collision. So if we look at the value of E, that's 3/4. If we consider the speed of separation, then the speed of separation is going to be 4 minus V, because they're moving in the same direction on our diagram. And then look at the speed of approach, that's 6 plus 2, they're moving together, so they're approaching it at a value of 8. And if we multiply then by that 8, that gives us that 4 minus V is equal to 6, and therefore V must be equal to -2 meters per second. Or in other words, A rebounds, moves in the opposite direction to its initial motion with a speed of 2 meters per second. Well, here's our final example, And you'll see here we've got two unknowns. Both of the velocities are unknown. Now if we've got two unknowns, we need two equations. But remember that we've got, as well as this new coefficient of restitution, E, or the law of restitution, we've also still got conservation momentum. So we can now write down two equations. One for E, and we can see that from that we get that E, which is 2 over 5, is the speed of separation. Well, the speed of separation is equal to v2 minus v1 divided by the speed of approach, and they're coming together at a total of 4 plus 6. So multiplying by 10, that gives us that v2 minus v1 must be equal to 4. So that's Newton's law of restitution. But we've also got conservation of momentum, and conservation momentum says that the momentum before impact, which is 4 multiplied by 4, plus 3 multiplied by negative 6 for B, is equal to 4 multiplied by V1 plus 3 multiplied by V2. If we calculate that, we get that negative 2 is equal to 4V1 plus 3V2. Now if we look at those two equations, then we can solve these simultaneously. So there's one equation, V2 minus V1 is equal to 4, and that's our second equation, 4V1 plus 3V2 is equal to negative 2. So if we take 4 multiplied by the top equation and then add it to the second equation, we find that we have 7V2 is equal to 16 minus 2, so that's 14. And so V2 is equal to 2 meters per second, and then V1 by substitution is equal to negative 2 meters per second. In other words, V2 or B turns around and moves in the opposite direction to its initial motion, and also A is in the opposite direction to its initial motion. And there we are with that, just put down neatly. So there we're using the two equations, conservation of momentum and Newton's law of restitution, to solve problems where we've got two unknowns. Well, that's the end of this video looking at Newton's law of restitution, and in the next video we'll be looking at the consequences of this idea of elasticity and what that means for energy when we have impacts.